Okay, so for this project, the biome that I chose is the Rocky Mountain National Park and biome, and hope you enjoy. So the basic description of this biome is the Rocky Mountain National Park is an alpine biome located in northern central Colorado. The Rocky Mountain Range forms the continental divide, which separates which way the rivers flow to the Pacific Ocean or to the Atlantic Ocean. So some abiotic factors are lakes, mountains, rocks, and other inanimate objects that are within the ecosystem. So some biotic factors are there are over 280 varieties of birds and over 1,000 species of flowering plants just within the park, and there's many different types of trees. There's mountain goats, bighorn sheep, bears, deer, hares, elk, and the list goes on. So where exactly is this biome? So here is my tour builder map of where the biome specifically is. So as you can see in the map, it is located in northern central Colorado, right there. And then here is a map of all similar biomes, you could say, I guess. And so that's where the Rocky Mountain National Park is, as it was shown in the map before. Then next we have the Himalayas, which is in Nepal. There, and then we have the Andes Mountain Range, which is in South America. And then back to the Rocky Mountain Range, which extends beyond the Rocky Mountain National Park. And so, what is special about Rocky Mountain National Park? Well, first of all alpine biomes have vegetation that is adapted to harsh climate conditions and high wind speeds. But in Rocky Mountain National Park, the north and south-facing sides of the mountains have very different ecosystems, including varying species, small changes in the climate, and small changes in the climate. So it also has the Trail Ridge Road, which travels on a scenic route above the tree line, and it is the highest paved road in the U.S. So some issues that are facing the biome right now. So the most pressing current issue is that the way the Rocky Mountain National Park ecosystem functions is being affected because of nitrogen that is being deposited in the park. So nitrogen emissions from Colorado and North America are associated with being deposited in Rocky Mountain National Park. So the source of these is from industrial, agriculture, and urban sources. So the Rocky Mountain National Park Early Warning System has done research about this, including research about weather, the timing of this weather, and the amounts of nitrogen in the park. So this led them to create a weather-based warning system, which will give agriculture producers information on when they can reduce environmental impacts. So this has an impact because it can tell agriculture producers it can tell them when to be more mindful of nitrogen emissions. So the Rocky Mountain National Park Early Warning System is obviously a collaborator and contributor to this issue. So there are no specific technologies regarding this issue as far as I can tell. And one other issue that the park is facing is the invasion of the Melatolis species. This has caused the characteristics of the soil to change because these non-native species are nitrogen fixing, and this affects the soil and how other plants use it. So if I had the resources to solve this issue, I would educate people about the fact that although planting this nitrogen fixing species may help enhance soil nitrogen, in a natural ecosystem, the increased nitrogen availability may not help native species. So extinction of the Metylicus species is a problem because the native species are not built for a change in the nitrogen levels of the soil, so the native plants are suffering. The impact of the actions that I suggested would be that there would be a higher awareness of what people could do when they're planting the species in a disturbed area, which could spread to affecting the natural ecosystem. So some contributors might be the Department of Environmental Conservation and the National Invasive Species Awareness Week Committee. So some new technology regarding this is eDNA, which is a species scanner that can run a DNA test on different species and stop the problem before it becomes one, and know where exactly the invasive species may be in a given ecosystem. So I have done a deep study into 6 different species, and which includes their their taxonomy classification, but I may not say some of the names right, but I'm gonna try. So the first vertebrate that I chose is a bighorn sheep, so or Ovis canensis. So the kingdom is Animalia, the phylum is Chordata, the class is Mammalia, the order is Cetardodicilia, the family is Bovidae, the genus is Ovis, and the species is Ovis canensis. So some adaptations are the bighorn sheep has developed a winter coat of fur for surviving harsh winter conditions. It also has the hoof split in half, so the tine of the hoof is split in half, and this is built for all terrain. So, and it also has a long range of eyesight for seeing predators and hiding places. So their population has been growing exponentially, and one relationship is parasitism with ticks. So the invertebrate that I chose is the Arctic blue butterfly, or Platypus random. So the kingdom is Animalia, the phylum is Arthropoda, the class is Insecta, the order is Lepidoptera, the family is Lycaenidae, the genus is Pleurotus, the species is Pleurotus random. So some adaptations are the gray coloration, which camouflages the butterfly into the ground, and it also easily mistaken for a moth, so that can also deflect predators. So their population has been growing logistically, and they have a mutualistic relationship with ants. So in which ants eat and are attracted to glands on the calipator that make sweet liquids, so the ant gets food and in return it protects the calipator. So the next the plant that I chose is the Colorado blue columbine, which is the Colorado state flower, which is also Equilegia cordula. So the kingdom is Plantae, the class is Magnolopisia, the order is Ranunculales, the family is Ranunculale, the genus is Aquilia, and the species Aquilia curel. So some adaptations are they've built up a strong aroma to attract hummingbirds and butterflies that pollinate them, and they also have varied petal colors, which is due to their different pollinators. So they also have a mutualistic relationship with hawk moths. So hawk moths pollinate the columbine, and then the hawk moths get food in return. So the next plant that I chose is the quaking aspen, or the Populus tremoduleus. The kingdom is Plantae, the class is Magnolopsia, the order is Magnophales, the family is Salicaceae, the genus is Populus, and the species is Populus tremoduleus. So some adaptations that aspens have developed are self-pruning, which when the branches fall to the ground and they fertilize the soil below. Also, it has adapted to different soil types, so its geographic range has increased. So its geographic range increases, and it also increases its geographical range. It has adapted to different moisture conditions. So one special relationship is commensalism with the ruffed grouse. The ruffed grouse eats aspen tree buds, but it doesn't greatly affect aspens because the grouse only eats specific tree buds. So the fungus that I chose is the fly agaric or fly amnedia mushrooms. So the scientific name is Amnedia muscaria. So the kingdom is fungi, the phylum is Basicomycota, the class is Arigomyctes, the order is Agricales, the family is Amniochaetae, the genus is Amnedia, and the species Amnedia muscaria. So some adaptations are the red top and white spots, which signals to predators that it is poisonous, and also the fact that it is poisonous, so predators who do eat it will suffer. So that also deflects predators, and it has a wide range of distribution, so it is fairly adaptable to different climates and ecosystems. So this population has been growing exponentially, and it has a mutualistic relationship with birch trees, where the fungus wraps around the roots and gets the tree sugars from photosynthesis. The tree gets nutrients that the mushroom takes up from the soil. So the invasive species that I chose is the Canada thistle, or Cirsium arbonis. So the kingdom is plantine, the class is Magnolopsida, the order is Asteroles, the family is Asteraceae, the genus is Circissum, the species is Circissum avernus. So 3 adaptations are it has lots of different habitats, so it has adapted to many different environments, as most invasive species do. Their seeds they work for many years, so the seeds can survive for many years before actually starting to grow. And the roots, they reach up to 10 feet below ground and are adapted to take hold in many different types of soil. So the Canada thistle has mutualism with honeybees. The honeybee pollinates the thistle, and then the honeybee gets food. So this is the food web that I created, which shows the interaction and the flow of energy between all of these species. So yeah, as you can see, the sun gives nutrients to the plants, which is photosynthesis, and then the primary consumers eat the plants, and then the secondary consumers eat those plants, and so on. So here's my bibliography. This is a link to the document with my bibliography region, and all the images that I used are from Google for use. And thank you for watching.